Okay, Year 10, welcome to your video tutorial. Today we're going to have a look at tree diagrams. Tree diagrams can be used to list the sample space for an experiment that involves 2, 3, or more steps. Okay, the branches of the tree are used to describe the change of each outcome or each step after the first one, after the second one, after the third one. How we work out the probability of obtaining an outcome for an experiment with more than one steps is done by multiplying the branches of the trees. Okay, the probability will depend on whether or not the selection is made with or without replacement. Cool. So this is an example of one. Okay, this scenario is a tree diagram for the fact a coin is tossed 3 times and a head or a tails is obtained each time. So it's for a coin being tossed the first time. Now, the very first time that coin is tossed, we go out, I might do that in a different colour. We go out here and here. There is a half chance that it is tails, and there is a half chance it is heads. On the next toss, there is again a half chance it's heads, half chance it's tails, based on each thing. And then again on the third toss, half chance, half chance, half chance, half chance, half chance, half chance, half chance. So, these are all the combinations. I could get 3 heads, okay, or I could get 3 tails. I could get 2 heads and a tail, or 2 tails and a head, a tails, a head, a tails, a head, a tails, a head, a tails, a tails and 2 heads, a heads and 2 tails, okay. So there is an equally chance probability, that being 1/8 of obtaining any one of those outcomes, okay. And the way I've worked that out, okay, is I've said, okay, first chance there's a half, then there's a half, and then there's a half. So the probability of getting 3 heads is a half times a half times a half. Remember, they're fractions, so I multiply the denominator. 2 times 2 is 4, times 2 is 8 to get me that. 1 times 1 times 1 is 1. Okay, that's kind of how it works. That's how that's how they're kind of laid out. Okay, here's our next scenario. Boxes A and B contain 4 counters each. I've got 2 greens and 2 reds in box A, and I've got 3 greens and 1 red in box B. Okay. A box is chosen at random. Okay. Randomly, one of the boxes is chosen and a single counter is taken out. What is the probability of selecting a red counter just from box A? Okay, from box A. So let's have a look at box A specifically. Okay, there is 4 counters. Okay, probability of red from box A is how many reds are there? There's 2. Over how many is there altogether in box A? 1, 2, 3, 4. 2 over 4. Always simplify it as a half. Okay, what's the probability of selecting a red counter from box B? So probability of a red counter from B is, how many reds are there? There's 1. How many are there altogether? 4. These should be revision. These 2 questions that we've done, okay, should be a revision. If you're then asked to represent the options available as a tree diagram that shows all the possible outcomes and related probabilities, I've already done it for you here. The first choice, the first selection, is a box. So remember, because it says you are randomly selecting a box. Okay? A box is chosen at random and then a counter. Okay? So you have a half a chance of selecting box A and a half a chance of selecting box B. Once you've selected the boxes, there is a half chance in box A that it is a red counter because there's 2 out of the 4. There's a half chance that that is a green counter because there is 2 out of that. In box B, however, of the 4 counters, only 1 is red, so it's a quarter chance, and 3 are green. Okay, so you have to be careful of the probability. So to work out the outcome or the probability of selecting a red counter from box A, it is simply a half times a half. A half times a half is a quarter. Probability of selecting a green counter, a half times a half, a quarter. The probability of selecting a red counter from box B, a half times a quarter. a half times a quarter is 1/8. Okay, so you have to be careful there. And the probability of selecting a green is a half times 3/4, which is 3/8. Okay, so all I've done is I've just multiplied my fractions along the line to work out the probability. If you're then asked what is the probability of selecting a box B and it being a red, all you have to do is go probability red B is super easy. Okay, this is the probability of overall getting a red B. The probability, you just follow the tree B, red, 1/8. Okay, the probability of selecting a red counter. Okay, this is the hard one, the probability of selecting a red counter. Well, I could get a red counter from box A if I go up here, and that was the probability of a quarter. Okay, and then they have the probability of selecting a red counter from B. That's 1/8. Okay, two ways to do this. If you want to do this in your head, guys, remember with adding fractions, okay, I need to find a common denominator. So I could change this to a denominator of 8, because that's common, okay. What have I done from 4 to get to 8? I've times it by 2, so I have to times the top by 2. So it's 2/8 plus 1/8 to get me 3/8. Or I can just pop it in on my calculator. So that's the probability of selecting a red counter. See how that's a little bit different this time, guys, because we're involving we're involving a scenario that involves more than one step. Okay, so we had to combine the probabilities of two separate events. And that's it, guys. That's tree diagrams.